Here's the question from page 12 in the higher booklet on trig equations. It's quite a good question in that it shows you lots of different things you need to be able to do in the exam and a way that they might all be pushed together in one question. The question gives us this situation here where we've got a factory fire alarm. Formula for its frequency is given here. And we've been asked to do two things with it. We've been asked first of all to sketch the graph, and we've also been asked to specify the percentage of time the alarm is inaudible to the workers. And it's important to note that when the frequency drops below 600, the alarm's not heard. So it's inaudible when it's below 600. Okay, so first things first, sketching the graph. I suppose I've skipped a very important step here in the notes in that I've taken this bit here with the two trig functions, 100 sine 180t plus 100 root 3 cos 180t, and I've replaced it with a single trig function. You'd be expected to do that yourself, as I've said over here. I've left it out to save time when I would be going over this in class and save some space. I think I'll put together another video just reminding you how this step has been done. Okay, so I need to sketch this. So I've got 200 180t plus 60. So first things first, I've got 180t. So that means to find the period of the wave, I need to do 360 divided by 180, which gives me a period of 2. That ties in quite nicely with the interval I've been asked to draw it between. Remember the 180 in front of the t means there's 180 waves in every 360. So being asked to draw it between 0 to 2 means we've only been asked to draw one wave. Okay, so examining the function, we know the biggest value this bit here can have, the biggest value 200 sine of anything can have is 200. So the maximum value for this curve will be 700 plus 200. The 700 of course coming from the front of the formula. Where does this maximum value occur? Well, the maximum value of a sine curve happens at 90 degrees. So we know when the angle is 90 degrees, we've got our maximum value. But remember, our angle is this. So I know 180t plus 60 equals 90 degrees. Taking away 60 from each side gives me that. Gives me 180t equals 30. Dividing by 180 gives me 1 over 6. Keeping it as a fraction, trying to stick to exact values as much as possible, rather than writing that as a decimal. Right, same again for the minimum value. The minimum value 200 sine any angle can have is minus 200. So our minimum value, the smallest value this function here can have, is going to be 700 minus 200. So that gives me 500. Again, minimum value of a sine curve is going to occur at 270. So when the angle is equal to 270, remember our angle, this here, so when our angle is equal to 270, we've got a minimum value. Again, solving the equation, subtracting 60, dividing by 180. Again, keeping a fraction rather than rounding off a decimal. Right, we've now got all the information we need to start drawing our graph. So, the period of 2, so I've set up my x-axis, but really it's got t along here because we're talking in time, in seconds. I've went from 0 up to 2, because that's the interval I've been asked to draw my graph in. I thought a bit about how many boxes to use along the bottom, how big to make my scale. All my things along the t-axis, the time axis, involve sixths. So, from 0 to 1, I've made sure I've got 1, 2, 3, 4, 5, 6 boxes. So each box represents a sixth. So, I know my maximum value of 900 occurs at 1/6. I know my minimum value of 500 occurs at 7/6. Well, there's one whole, so 7/6 is 1/6 after that. So there we go. The roots, where it would cross over this dotted line right here, well, we need to think about it. The roots are going to be halfway between the maximum and minimum. There's 2, 3, 4, 5, 6 boxes between them, so the halfway point is going to be 3. 1, 2, 3. So, there. And again, another root, the fact that this will be symmetrical here, I've got 3 there, so if I go along 3 this way, I will have my other root. Okay, all that's left to do is draw a nice smooth curve. Now remember, you must draw that little bit there as well. Some folks tend to forget about that and just go from their maximum point up to the end here. So remember about any extra little bits there. So we've got our sketch. The whole point in the sketch is this will be useful to help us identify when the frequency is below 600. So if I have 600 here, I know I'm expecting 2 roots round about there. Of course, it's not enough to just read it from a graph. My curve's not accurate enough, so I need to solve algebraically. But it lets me know that this is the interval I'm interested in here, so between the 2 solutions. Okay, now it's time to solve the equation. I've got my original formula, and I'm interested in where it equals 600. Of course, these points here. That'll help me determine when it's below 600. So I've set up my equation. I'll need to deal with this 700 first, so I'll subtract that from each side. I'll need to deal with this 200, so I would divide by 200. Of course, negative 100 divided by 200 gives me negative 1/2. Alarm bell should be ringing. We've got an exact value here. So I'll take the inverse sign of 1/2, dropping the negative, of course, because that'll come into play in my ASTC diagram. Inverse sign of 1/2 is 30. Okay. Now, which quadrants am I working in? I've got sine and it's negative. So, sine is positive in the first and second quadrants, so we're not interested in those. So it's negative in the third and the fourth. So, our solutions lie in the third quadrant. So I need to do 180 plus my original little building block there, which gives me 210. And in the fourth quadrant, it's 360. Take away building block, take away that 30 degrees. Gives me 330. Now, this isn't what t equals. This is what 180t plus 60 equals. So, setting up an equation with my first solution, 180t plus 60 equals 210. Solve it as normal. Take away 60. Divide by 180. gives me 5 over 6, which sort of ties in with my diagram there. Remember, my diagram's not too accurate, but I mean 5/6, I'm pretty close there. Same with the second solution, the one in the fourth quadrant. So 330, I will need to take away the 60 and then divide by the 180 and give me that. So I have identified that that happens 5 over 6 and 3 over 2. Now, we can finally answer, I suppose before we even answer the question, remember, if we were looking for multiple solutions, we're dealing with 180t here, and we've got a period of 2, so it means these solutions here would repeat every 2. So if I kept adding 2 to these solutions here, I'd get a new set of solutions. However, we're not interested in those, we're just interested in what happens on one cycle. Okay? So, the time the alarm is inaudible, we can't hear it when it's below the 600 at this point here. Well, that's between 3 over 2 and 5/6. Just to continue with the non-calculator theme, converted my 3 over 2 to 9 over 6 just to help me with the subtraction. Gives me 4/6, which simplifies down to 2/3. Then been asked what percentage of the time is the alarm inaudible? Well, it's inaudible for 2/3 out of 2 seconds. Because remember, this wave takes place over 2 seconds. To convert any fraction to a percentage, you would just need to multiply by 100. 2/3 divided by 2. Well, 2/3 divided by 2, 2/3 shared between 2 people, would mean they'd get 1/3 each, times 100. Hopefully you should know that 1/3 is 33.33%. Okay, so there's a solution to page 12 in your notes.